Hello, hi everyone, good afternoon. So, welcome back and let's begin. So, we have learned what is reflection, what are the laws of reflection. I hope you remember this. And today we are going to start with spherical mirrors. And one of them, there is a convex mirror that we are going to discuss today. So, welcome you all, welcome to the Infinity Learn by Sri Chaitanya, and this is our series for grade 10 Pioneer. Alright, so let's begin. My name is Dr. Akash. This is about me. I have PhD in physics from National University of Singapore. Hi Bhuvan, good afternoon. So welcome everyone. Yeah, all of you know about it, right? I need not spend more time. And let's begin. So now in your surrounding you see lot of different objects. Some of them they are curved. These are the curved shapes. So if these are eager to see me, okay, nice Bhuvan, thank you. So you see these curved surfaces. So can all these curved surfaces called as spherical mirrors? What do you think? Are all these surfaces spherical mirrors? Answer is no. Why? Because there are certain properties for the mirror to be a spherical mirror. This curved surface, it can be a cylindrical mirror, can be a conical mirror, can be elliptical mirror. You see this one? This looks like an elliptical mirror, right? So this can be any kind of shape. So there is a very specific shape, there is a sphere. In maths, you must have learned how the sphere looks. Sphere is like a circle in 3 dimensions, like your football, right? That is a sphere. So if this mirror is a part of that sphere, then we call that as a spherical mirrors. So let's understand what are the different types of spherical mirrors. So you can complete a sphere here. You see there is a spherical shape, right? Even this one is a sphere. So what is this spherical mirrors? It is a mirror. It is a part of the sphere, part of a hollow sphere. So if you complete, this will look like one sphere, that will look like another sphere. Now there are two types of spherical mirrors, and what are those? Here it is written convex and there is a concave. So what is the difference? You see this blue side and there is a white side here, right? This white surface is the reflecting surface and this blue one is the silver surface. There is a silver surface and this one is a reflecting surface. So if the reflecting side is outside, this is a reflecting surface. If it is outside, then we call that as a convex mirror. If the reflecting surface is inward, so this will look like cave is like you go inside, right? So that is a cave like structure. So that is how it got a name, concave. So there is a concave mirror and this one is the silver surface. Okay, so this is how these two mirrors are defined. They must be a part of a hollow sphere, and if the reflecting surface is outside, it would be convex. Reflecting surface inwards, it would be concave mirror. So now if all the rays, you see these rays, they are parallel to each other. So when all the rays parallel to each other fall onto this mirror, what will happen? They all converge. So it is which type of mirror? This is a concave. If they fall onto concave mirror, they converge. Converge means all of them come and meet at a one point. And if they fall on a convex mirror, then what will happen? They diverge. Diverge means they go away from each other. So here these rays, they are going away from each other. So they are never going to meet each other. In that case, what we do? We extrapolate them backwards and they appear to meet at one point. So that is a convex mirror. Let's understand more about these mirrors. So now these are the terms you should know and they are present for both the mirror. It can be a concave mirror, can be a convex mirror. here we have concave mirror. So pole is this point. This is the aperture. What is the aperture? Aperture is the reflecting part. In your camera lens, you must have seen the aperture, right? Aperture is nothing but the camera or the part of the camera which is going to reflect. So now this is the aperture. So in that aperture, or this is a reflecting part, pole is the center of it. Then what is this C? C is nothing but center of curvature. So this is the curvature. So if it is a hollow sphere, so this C is the center of that hollow sphere. If you join this C with the mirror, then what is this? This is going to be the radius. It is same everywhere. You can join any 2 points. The radius is going to be same. That is the center of curvature and radius of curvature. Then there is this imaginary line which is passing through the center of curvature and the pole. This imaginary line is called as principal axis. And there is one more point here, this point F. Do you know what is this point? So this point is a point where all the rays either they converge if it is a concave mirror, or they diverge from this point. So this point is called as focus. If this point is on the principal axis, it is called as principal focus. Clear? So these are the different names you should know. If it is concave mirror, so this is a concave mirror. You draw this hair-like structure, that means there is a silver part. Okay, this is the imaginary line which is our principal axis. So there is a pole, this is the focus, and there is center of curvature. Now when all the rays fall on it, which are parallel to the principal axis, these are the incident rays, they all converge to the focus on the concave mirror. If it is convex, what will happen? If it is convex mirror, there is a silver side. So now when it is a convex mirror, the focus and the center of curvature are behind. So focus is here and center of curvature is here, right? They both are behind the mirror. Now these are the incident rays, they will diverge. And how they will diverge? They appear to come out from a single point, which is this focus, right? So these are the basic differences and terms you should know. There is something more you should know, that is the radius of curvature is 2 times the focal length. What is this F? F is nothing but focal length. So how it is defined? It is this point F and this point P. The distance between them is called as focal length, and the focal length is half of the radius of curvature. Clear? Now let's learn the ray diagrams and the image formation by the convex mirror today. We'll learn about convex mirror now. Concave mirror we'll learn in the next class. So these are the 4 spatial rays. These are the most important rays. If you learn how these 4 rays pass, or how these 4 rays will get reflected from the mirror, your life is sorted. You don't have to learn anything else. Just using all these 4 rays, you can find out how the ray diagram should look like. So that is why these are most important. These are like spatial rays you should remember. The first one, a ray parallel to principal axis. Now you see here, there is our incident ray. There is an incident ray. When the incident ray is parallel to the principal axis, this dotted line is the principal axis. Now what will happen? It is falling on the reflecting surface, and what will happen? It diverge, and it appear to diverge from the focus. So this point here is the focus. So when this ray appear to diverge from the focus, this is how it should look. It can be coming from any direction. Let's suppose there is another ray parallel to the principal axis. Again it will diverge, and how it will diverge? Something like this. this would be the, there is an incident ray and there is reflected ray. Similarly here, this one is the incident ray, there is a reflected ray. Now, okay, we learned this, it is diverging, but now why only in this manner? Because let's suppose there is an incident ray, you can see here, there is a reflected ray, this one. Now, this is a point of incidence. There is, what is it? Point of incidence. If you connect it with the center of curvature, then what is this line? This line is nothing but radius. Is it visible? Okay, I'll change the color. This point here is the point of incidence. There is our center of curvature and this is the radius. So now you remember this is a spherical mirror. So if it is a spherical mirror, something like this, in 2 dimensions sphere is nothing but a circle, correct? In 2 dimensions. If this is the center of this circle and there is a radius, what is this line here? This is a tangent, correct? This line here is a tangent. So similarly at that point you can draw a tangent, something like this. So there is a tangent. So if this is the radius will make an angle. What will be this angle here? This angle is going to be 90 degree. Yes, nice. Ashika, correct, awesome. Awesome, Ashika. Yes, there is a tangent and this is the radius. When you extend the radius outwards, it will make an angle 90 degrees, right? Can you see here? This angle is 90. So now you extend this here in front. So this is the, what is it? There is a normal. We have learned the laws of reflection. In that, so we have, this one is the angle of incidence. This is the normal. There is the angle of reflection. So even in this case, angle of incidence and angle of reflection, they are equal. Clear? So it follows our laws of reflection. So that is how you should draw all the diagrams. This is the first one. Incident ray parallel to the principal axis. After reflection, they all diverge. Now let's go to the second case. Here, this is the second case. The incident ray is directed towards the focus. This is our focus here. So there is an incident ray which is directed towards the focus, right? There is a focus. So now in this case, what will happen? There is an incident ray and this is the reflected ray. So again, the reflected ray is parallel to the principal axis, right? The reflected rays goes parallel to principal axis, and again this point here, if there is a focus, there would be somewhere here. It is a center of curvature. There is a point of incidence. If you join these two, what will be this line? There is nothing but our radius. If you extend this radius, what is this? There is a normal. If there is a normal, this is the incident ray and the normal. So this is angle of incidence. This is our angle of reflection. So angle of incidence and angle of reflection, they are equal. So that is why whenever the ray is directed towards the focus, the reflected ray goes parallel to principal axis. There is a second ray. Yes, case 2 is a vice versa of case 1. That is correct. Nice, Anshika. Awesome, correct. Now the third one, a ray is directed towards the center of curvature. So you see here, the ray is directed towards the center of curvature. So there is our incident ray, which is directed towards this point would be center of curvature. So in that case, you see what is happening? The reflected ray, this white one is the reflected ray. It retraces its own path. The path of the incident ray and the reflected ray, they retrace, they lie on the same line. So why is it so? And the explanation for that is this point and this point is the radius. So the incident ray is along the normal, right? Incident ray is along the normal. So that means angle of incidence in this case is 0 degrees. If the angle of incidence is 0, angle of reflection is also going to be 0 degrees, right? Which is same as angle of reflection. So that is the reason they will retrace their own path. There is a third type of ray. Now the fourth one, and very easy, the ray which is directed towards the pole. There is a pole here. Now there is somewhere here which is a center of curvature. So what is this line? The principal axis is nothing but our, there is a radius, extension of the radius. So this will act like a normal. So this is the normal. There is the incident ray. And this angle will become our angle of incidence. Now it will get reflected. So this is a reflected ray and this will be the angle of reflection, right? So this is how all the 4 rays you need to know. Yes, incident angle is equal to reflected angle, correct. Hi, bad bro writer, you are present, awesome. So now when it is directed obliquely to the pole, what will happen? It will get redirected and it will make an equal angle with the principal axis. The principal axis in this case will act like a normal, correct? Great. So now let's understand the image formation by this convex mirrors. So we have learnt all these 4 rays, but image formation by the convex mirror is very simple, very easy. For concave, we have a lot of different cases. For convex, it is very simple, very straightforward. So let's understand why it is so. First, object is at infinity. So which case you will call it as an infinity? Something which is very far. Let's suppose there is our mirror. So there is a pole and this distance here. What is this distance? It is object distance u. So when you call something to be at infinity, if this u is much greater than r. What is the r? R is the radius of curvature, or you can say much greater than focal length. If u is much greater than focal length, we say that object is at infinity. Hindi mein bhi boliye, okay, I'll try in Hindi also. Why convex mirrors used in rare wave? Yes, Anshika will go to that. थोड़ा हिंदी में बात करते हैं ताकि सारे बच्चों को समझ में आ जाए, है ना? तो यहाँ पे ऑब्जेक्ट इज एट इंफिनिटी. हमें यहाँ क्यों बोला ऐसे कि ऑब्जेक्ट इंफिनिटी पे है? इंफिनिटी मतलब ऐसा नहीं कि लाइक इनफाइनाइट, दूसरा एंड ऑफ द यूनिवर्स. इट इज नॉट पॉसिबल, राइट? दिस कुड बी अ ट्री. एक कोई तो बड़ा सा ट्री है विच इज सम, लेट्स सपोज दिस u is, let's suppose u is 1000 meters. That is nothing but 1 kilometer. And the focal length, अगर मान लो focal length इस मिरर का है 1 meters. So compared to 1 meter, this 1000 meter is also infinity. बहुत दूर है, right? तो इस, we are from Andhra Pradesh. Nice. All right. Okay, so you need English. Let's say I'll try to mix and match both Hindi and English. So when you say this is only 1 meter and this 1000 times larger, focal length से जो object है, it is 1000 times larger at a distance, then we say that it is at a infinity. Okay, infinity मतलब ऐसा नहीं कि पूरा दूसरी दुनिया से कहीं से तो रे आ रहा है ना? ठीक है. So now these are the incident rays. So whenever the light comes from the object at infinity, जो incident rays है वो हमेशा कैसे रहेंगे? They are parallel. Yes, I'll mix and match both. So सारे जो incident rays है, they are parallel to each other. And now अभी क्या होगा? They all diverge. ये सारे दूर दूर भाग रहे. These are the reflected rays. They diverge from each other. And because of that, they diverge or appear to diverge from this point, which is our focus. तो यहाँ पे क्या होगा? Image will form at the focus. Let's suppose there is a sun and you put a convex mirror in front of the sun, you will get the image of the sun at the focus. That is the meaning, है ना? तो यहाँ पे image is formed behind the mirror. It is highly diminished. You see, the object is very large, but the image is like a point size. इतू सा है, बहुत छोटा image है. There is a point size or highly diminished image. Nice, and Ashika. Yes, I'm trying. And this virtual and erect. We'll come to this, why this image we are calling it virtual and erect. Thoda sa, we'll move the object a little closer so you will understand. Now, the second point, it is between infinity and pole. तो कॉन्वेक्स मिरर इतने सिंपल होते हैं, इतने आसान होते हैं समझ में. यू कैन प्लेस द ऑब्जेक्ट एट एनी प्लेस, कहीं पर भी रख दो, है ना. अगर इफ यू हैव द मिरर ऑफ योर कार, तो उस कार के मिरर में आपको जो दूसरी कार है जस्ट बिहाइंड योर कार, यू कैन सी दैट, और आपको सन भी दिखेगा इन द सेम मिरर. सो ऑल दीज ऑब्जेक्ट्स, you can place the object at any distance and its image will form in that small mirror of your car. So these are those convex mirror, है ना. Hi Ayushman, hello. English, yes. So now you remember हमने 4 different rays पढ़े थे. The first ray which is parallel to the प्रिंसिपल एक्सिस, दिस इज अ फर्स्ट इंसिडेंट रे. तो अभी क्या होगा इस केस में, ये इंसिडेंट रे यहां से रिफ्लेक्ट हो जाएगा. कैसे रिफ्लेक्ट होगा, इट विल रिफ्लेक्ट फ्रॉम द फोकस, है ना, समथिंग लाइक दिस, इट विल गेट रिफ्लेक्टेड. सो नाउ वी नीड 2 rays. Whenever you want to form the image, minimum 2 rays are required. So now this is a second ray. ये दूसरा इंसिडेंट रे है, it is falling at this place. So now this is directed towards the center of curvature. So whenever, जब भी ये इंसिडेंट रे center of curvature की तरफ डायरेक्टेड होता है, what will happen? It will retrace its own path. Now you see this is a reflected ray and there is also a reflected ray. So these rays, ये दोनों से दूर दूर भाग रहे, they are diverging. So whenever the rays are diverging, they are never going to meet. So in that case हम क्या करेंगे, इसको backwards, मिरर के पीछे backwards retrace करेंगे. So if you retrace them backwards, यहां पे एक पॉइंट मिलेगा. So ये जो पॉइंट है, where they appear to meet, and where is this location? It is between the pole and the focus. So इस रीजन में इमेज फॉर्म होगी, है ना. So image will look something like this. There is an image. So what are the properties of this image? How much money earn? I don't earn any money from this YouTube. Okay. Yeah. So what are the properties of this image? This image is formed behind the mirror. There is a mirror. Image is formed behind the mirror and it is diminished. Diminished matlab, you see the object height, there is the height of the object and image is smaller. So that is the meaning of diminished, matlab छोटा हो रहा है ना. Then virtual and erect. So whenever image is forming behind the mirror, that is going to be virtual. जब भी मिरर के पीछे इमेज बनती है, वो कौन सी होती है, वर्चुअल इमेज. एंड इरेक्ट मतलब अपराइट, सीधा सीधा ऐसा अगर पहने तो इमेज भी इन द सेम वे फॉर्म हो रही है ना. इफ दिस ऑब्जेक्ट एंड इमेज इज लाइक दिस, लाइक अपसाइड डाउन, दैट इज गोइंग टू बी इन्वर्टेड. दिस इज लाइक अ अपराइट इमेज. सो दैट इज द मीनिंग ऑफ इरेक्ट. सो दीज आर द प्रॉपर्टीज ऑफ दिस इमेज. यस, sometimes in the concave we have real and inverted. We are going to learn that in the next video. 1,000 rupees per month, that's nice bro, congrats. I get paid, like I have a salary from this YouTube. I don't earn, I have a fixed salary. All right, so now let's solve some MCQs. यहाँ पे MCQ क्या है, In the case of plane mirror, जब भी plane mirror होता है, then we observe the lateral inversion. Can you see the lateral inversion? Our right hand becomes the left hand, है ना? So that is the meaning of lateral inversion and virtual image. Image is also virtual. Now, do we see lateral inversion in case of spherical mirrors? जब भी कोई spherical mirror होता है, do we get the lateral inversion? That is a question. And answer is, you see, there is a mirror. In that mirror, this girl, her right hand became the left hand, है ना? So even in the, no, Anshika, even in the all the spherical mirrors, you will see the lateral inversion. So answer is yes. Where am I from? I am from Pune, like born and brought up with Pune. So is it true? Say that convex mirrors always form? Yes, convex mirrors always form virtual and erect image. So there is no way convex mirror can form a real image. No way. Because where do we use this? We are going to go to the applications of these convex mirrors, but they are used in car vehicles, right? The side view mirrors of the car, there is a convex mirror. So why it is convex? Because you can see lot of different objects. Let's suppose there is a mountain. The whole mountain you can see in the small window of that mirror, right? That is the advantage of this convex mirrors. So what are the applications of the convex mirrors? So we know this ray diagram. So convex mirror form there is a virtual and erect image, right? So this image is formed behind the mirror. It is diminished, virtual and erect. So these are the properties of this image. But there is something very interesting about the convex mirror. And what is that? It is a field of view. So field of view का क्या मतलब है? कोई बता सकता है? What is field of view? Yes, that is correct, Spring Carnival. That is the reason ambulance is written like flipped. There is a inversion because you see in the car mirror, what is it? We get the lateral inversion, right? So that is why this, I told this same question in the last class. The ambulance word is written laterally inverted. Maximum distance which can be seen. Yes, okay, I'll tell you the field of view for different mirrors. If it is a plane mirror, this is a plane mirror. In that plane mirror, this would be the field of view. So you can see the object only when they are in front of the mirror. There is a field of view of this plane mirror. If you have a concave mirror, there is a concave mirror, this one will have even smaller field of view. So it will have only this much field of view. So when you place the object only within this region, you can see the object in the mirror. There is a field of view of the concave mirror, even smaller. But for the convex mirror, you see it has very wider field of view. So you can see lot of different objects, like object placed in different parts. You can get the image in the convex mirror. So convex mirror will have very high field of view. Okay. So now that is the reason they are used in the rear view mirrors of the vehicles, because of the wide or large field of view. Then they give a erect and diminished images. So now why it is important? Why do we need erect image? Because let's suppose हमने कोई मिरर लगा दिया कार को और उसमें अगर इन्वर्टेड इमेज मिलेगी तो पीछे से जो कार आ रही है इट वुड बी लाइक अपसाइड डाउन. It would be confusing, right? If you look at the side mirror and the car behind you is upside down, we don't want that. We want, क्या चाहिए हमें? जो image चाहिए, it should be proper, it should be upright. So that is another advantage. Why do we have this mirrors as a side view mirrors in the car? You see, there is a car mirror and there is a tree. You see such a large tree, you can get the image in such a small window. If it is a plane mirror, it would be very difficult to see this large tree in the plane mirror, and if it is a concave mirror, it would be impossible to get the image of the tree in this small window. Okay, yes. So they have wider field of view than plane mirrors, so that is another advantage. Now these mirrors, convex mirrors, can also used as a security mirrors or blind turn mirrors. So what are these? In a shop, in a small shop, the shopkeeper, let's suppose the shopkeeper is sitting somewhere here, right, and the shopkeeper want to see what is happening in the whole of the shop. Either nowadays we have like security cameras, that is even better, but when there was no security camera, they used to have this security mirrors. So that mirror would be just at one corner, from like the shopkeeper can see only that mirror and he will get the idea what is happening. If there are any thieves, like are they stealing something from the shop, that he can just check from this one mirror. And there is a blind turn mirrors. So sometimes what happen, the roads are very narrow, बहुत छोटे छोटे पतले पतले रोड होते हैं, है ना, and if they roads are something like crossing at 90 degree, अगर यहाँ से कोई vehicle आ रही है, so this vehicle, मतलब इसको पता ही नहीं चलेगा if there is something coming from this side or this side. No way this person can see these objects. So in that case we have these blind turn mirrors. So अगर एक mirror यहाँ पे लगा दिया, so in that mirror you can see anyone who is coming from this side, right? Or it will depend like how many mirrors are possible. They will arrange the mirror such that you can see दोनों साइड से अगर कोई ऑब्जेक्ट लाइक कोई व्हीकल, कोई अनदर कार कुछ आ रहा हो, है ना. So that is how these mirrors, convex mirrors, are used. So now let's solve one more question. The convex mirror cut into two equal parts. एक हमने convex mirror ले लिया, उसको क्या किया, break into two equal parts. The focal length of each part is, तो focal length क्या होगी दोनों parts की. So we have, you understood the question? So we have a large convex mirror. There is a convex mirror, let's suppose. There is a center and this is a focus. So this will be the focal length. Okay, not this one, sorry. Okay, this will be the radius of curvature. This is a radius of curvature. What will happen to the focal length? Focal length is this distance from here to here. This is a focal length. Now what we did, we break this into two pieces. So they will look something like this. There is a first part and now there is a second part, and this was our center of curvature. But now they are still the part of the hollow sphere, right? So if you join this, there is still the radius of curvature. There is still the radius of curvature. In both the cases, we have not changed radius of curvature. If radius of curvature is same, what will happen to the focal length? Hi YouTuber Chand Ji. Yes, that is going to be equal. Nice, that is correct. Why it is equal? What is the focal length? Focal length is r by 2. Radius of curvature divided by 2. In this case, what is the focal length? It is simply r by 2. For both these mirrors, it is going to be equal, and this is equal to the uncut mirror. So that is the equal to the uncut mirror. This is the correct option. Clear everyone? So alright, that's it for today. Thank you so much. You can join this Telegram channel and you will get all the PDFs. Lot of questions will post in this Telegram channel. So that's it for today. Spring Carnival, Ashika. Bye bye everyone. Take care. Enjoy. See you again in the next class. Tomorrow I think you will have bio and maths. I don't know like who is teaching grade 9 and grade 10, but you have bio and maths tomorrow. Alright, bye bye. Take care.